All right, when we get to distance, speed, time problems, you're not going to be tested on this for this unit, but I'm just going to show you how it works because this becomes a very big part of a couple of the units in Math 20-1. So I'm going to take you through how distance, speed, time works. So it says a student drove 1,245 kilometers from Edmonton to Vancouver in 16.5 hours. This included a 1-hour stop in Golden and a 30-minute stop in Kamloops. She averaged 100 kilometers per hour on the divided highways and 75 kilometers per hour on the non-divided roads. So, if we know that speed is equal to distance over time, which means that distance is going to equal speed times time, and time is equal to distance over speed, then I'm going to create a little chart. So, my chart in this case is going to separate the highway travel from the mountain roads. Then I do my distance, my speed, and my time. Now, in this case, it says how much time did you spend on the divided highways? Well, I'm going to say that the highway I'll represent with X, and the mountain roads I'll represent with Y, because this is what we're actually trying to solve for. We know the speed on the highway was 100, and the speed on the mountain roads was 75. And lastly, if distance, as we can see up here, is equal to speed multiplied by time, then the distance that they traveled on the highway was 100x, or 100 times the amount of time spent there, and the mountain roads is going to be 75 times y. Now, how does this help us create our equations? Well, if I look at the information that I have, then I can say that if I take the total time that she drove, and then I have a 1-hour stop and a 30-minute stop, I'm going to take away 1.5 hours from there, which means the total time is going to be 15. Well, then I can state that the time for one plus the time for the other is going to equal 15. Secondly, if I know the distance is going to be 100 times the amount of time on the highway and 75 times the amount of time on the mountain roads, then 100x plus 75y is going to equal the total distance, 1245. And then at this point, I can solve it the same way that we did the last couple of them. I'm going to isolate one. Doesn't really matter which one. Y is equal to 15 minus x. So 100x plus 75, 15 minus x is going to equal 1245. $100x minus 75x plus 1125 is going to equal 1245. $25x is going to equal 120. where x is going to equal 4.8. If y is equal to 15 minus 4.8, y is going to equal 10.2. So the student spent 4.8 hours on the divided highways. The second distance speed time problem, same concept. A small cruise boat took 3 hours to travel 36 kilometers down a river with a current. On the return trip, it took 4 hours against the current. Find the speed of the current and the speed of the small cruise boat in the still water. I'm going to make my chart again, and I'm going to say that I'm going to have my distance, my speed, my time. And I'm going to say that this is going to be downstream. And this is going to be upstream. Now, if the speed, I'm going to say that the speed of the boat is going to be x, and the speed of the current is going to be y. Well, if I'm going downstream, the speed of the current is going to push the speed of the boat faster. If I'm going upstream, then I'm going to have the speed of the boat, and then the speed of the current is going to push against the speed of the boat. In this case, the time was 3 hours. In this case, the time was 4 hours. If the time is, or sorry, the distance is going to be the time multiplied by the speed, then this would be 3x plus y, and this would be 4x minus y. And now I have my two equations I can create. Well, the distance, 3x plus y, is equal to 36. At the same rate, for x minus y, the distance to travel upstream is also equal to 36. I can say that this would be 3x plus 3y is equal to 36, or 4x minus 4y is also equal to 36. I'm going to do this using elimination, and I'm going to, because I'm trying to find the speed of the current and the speed of the cruise boat, it doesn't really matter. I'm going to, in this case, choose to cancel out the y's. Now, it doesn't matter because I have to do the same thing for both. I'm going to have to multiply everything here by 4. I'm going to have to multiply everything here by 3. And I'm going to say that this is going to be 12x plus 12y is equal to 4 times 36, or 144. And 12x minus 12y is going to equal 3 times 36, or 108. And in order to cancel out the y, I'm going to, because they have opposite signs, add these two together. And I'm going to say that 24x is going to equal 252. Or x is going to equal 10.5. If x equals 10.5, then 3 times 10.5 plus 3 times y is going to equal 36, or 31.5 plus 3y is going to equal 36. When I subtract that from both sides, 3y is going to equal 4.5, or y in this case is going to equal 1.5. And then I state my answer. The speed of the current is 1.5 kilometers per hour. And the speed of the boat is 10.5 kilometers per hour. And that's it for the word problems.